So hi guys. Hello. So I'm gonna start the conference by a presentation on RubyMotion.
What's that?
RubyMotion, yeah. So here's the thing. According to my estimate, half of you guys here don't know what RubyMotion is, or not that much, unless I'm mistaken. So because a lot of people are actually students here today, so I have to start describing a little bit what RubyMotion is before going to the meat of the presentation. So I would like to start describing the state of mobile development today. Right now, as you know, there are two major platforms if you have to do apps for mobile platforms. No, there are two platforms if you want to do apps for mobile devices. Basically, you have iOS and Android. And if you compare them, they look very much alike. They didn't used to look very much alike in the past, but now they do. And these are two separate platforms, different set of APIs. If you look at the market share, clearly Android has more market share, even if this year iOS grew a little bit more and Android fell. These are true. These are numbers that I picked from the internet. So if it must be true, right? I picked them from IDC. IDC is a marketing website. You will like it. Apparently, it's due to the iPhone 6. The iPhone 6 really helped. Anyway, so the thing is that if you want to do a mobile app, you can't really do iOS only anymore. You have to target Android as well. So you need to go cross-platform. You need your app to work on both iOS and Android. And you kind of need to go native as well. This is our opinion, of course. You can use a purely cross-platform toolchain, which is usually based on web technologies. There are many products that allow you to do that, but it's never as good as a native app. Eventually, there are many. I mean, there's a very big debate about that, native versus web. Recently, there was this blog post, web versus native. Let's concede defeat, by apparently a web developer, someone really into the web development community. It basically says that it's impossible to compete with native APIs if you want to make a very responsive application and if you want to call all the features of each platform. So he basically says that web should do something else on mobile. But you can have your own opinion there, of course. But we believe that native apps provide the best user experience because they really let you call everything on the platform. And we also believe that consumers, they want the best user experience as well. Consumers will see if the application doesn't perform as other apps, especially apps written by the platform manufacturer. So if you're making apps for consumers, you probably want to go native, in our opinion. And it's very hard. So as my favorite person, Arnold Schwarzenegger, said, "No pain, no gain." It's more difficult to write native apps than web apps, but no pain, no gain, right? So let's look at the platform architectures. Let's start with iOS. iOS is explained as Apple by Apple using 4 layers. You have core REST, core services, media, and Cocoa Touch. And each platform is responsible for its own layer of APIs. The core REST provides the kernel, BSD, userland. This is stuff you normally never call when you write an app. Core services provide the base APIs of everything else. There you will have the foundation framework, which provides all the built-in classes, such as string, array, dictionary. You have core data, a library to do object persistence. The media layer provides UIKit, probably the biggest framework. Like it has all the widgets classes, like what's a button, what's table view. And finally, on top, you have the Cocoa Touch layer. This layer provides additional services that you can use on your app. For instance, accessing the address book, accessing the game kit services. And so you will need the three first layers. You don't really need core REST. And all these layers are accessible in C or Objective-C. And you have to use Xcode also, Apple's IDE, right? For Android, it's almost the same thing. You have 4 layers. You have Linux, core libraries, the JDK, and application frameworks. And again, the Linux layer is mostly drivers, so you don't really need that to write when you write an Android app. Core libraries are actually C-level libraries that are used to implement the rest of Android. So you will have like OpenGL or SQLite. Again, you don't really need to call these because usually they are provided as Java APIs. So the JDK is the implementation of Java. So there you will have the whole implementation of Java written by Google. And finally, you have all the Android Android classes. And the same goes on here. The last two layers are Java APIs, so you have to call them from Java. So you have to use Android Studio as well. That's a different IDE. So if you look at native development, you have this table here. For iOS, you need to use Objective-C or Swift, which both allow you to call C on Objective-C APIs. For Android, you need to use Java. You have Xcode on the iOS side, Android Studio on the other side, and you need to call the iOS SDK APIs on the iOS side, and the Android SDK APIs on the Android side. So you have to juggle between languages, environments, and APIs. So can we make this simpler? Of course, yes, right? This is why you guys are here. So basically, RubyMotion lets you write native mobile apps. Native is very important because they are truly native apps. It's cross-platform, iOS, Android, and you can also do OS X apps, but most people don't really want to write OS X apps these days. It's designed for Ruby programmers. That's the main goal. And the idea is to provide, the main idea now is to provide a consistent experience for cross-platform native development. So we want to provide the same experience when you target both iOS and Android. So if you look at this table, RubyMotion basically replaces the first two rows. The language is Ruby on both platforms. And instead of using an IDE on each platform, you can use your the editor you want and the terminal. As you can see, you still need to call the iOS APIs on iOS and the Android APIs on Android. It doesn't provide like a 100% cross-platform thing. This is because we really want people to write pure native apps. So each app has to call the native API widgets. But we believe that by allowing by providing a common language on both platforms, it actually helps. And also, you don't need to switch between IDEs. So you can basically write an app that calls very specific platform APIs, and then you can share the rest of the code. And this is our vision of doing cross-platform development. And so for that, we have unified Ruby runtimes, which are custom implementation of the Ruby language for each platform. So we actually re-implemented the Ruby language for each platform we target. So we don't use the standard implementation of Ruby. We wrote our own. And for iOS, we rewrote Ruby on top of the same runtime that powers the Objective-C language. It's basically a library that lets you create classes, methods, and objects. And we use the exact same runtime. So basically means that when you write Ruby code for iOS, all the objects that you create are actually true Objective-C objects. And therefore, you can access the entire iOS SDK classes natively. There is no bridge here. We don't need to convert classes. We don't need to forward messages. You really access everything from scratch. And also, when Apple releases a new version of iOS, you get to access everything. So we need to update the compiler files. I will explain that later, but you get everything for free. We don't need to write wrappers for each API. And Android is the same. For Android, we rewrote Ruby on top of GNI, which is the C API of the Java Virtual Machine. And it is the same level as Java. So it is the exact same thing. In Ruby apps for Android, RubyMotion apps for Android, all the objects that you create are truly Java objects. And again, all the stuff that Google defines as Java are automatically available in Ruby as if it was a Ruby class, but it is because we use the same runtime. So this is our vision. So for iOS, this is a Hello World. Most of you guys are already familiar with that. Just a basic Hello World file. Most of you guys probably want to use a DSL or something, but all the classes that you see here, for those who don't really know, are actually true Objective-C classes. Like UI View Controller is an Objective-C class defined by Apple, but you can just use it here in Ruby as if it was a Ruby class, right? You can call .new on it. Most of the methods that you see here are actually Objective-C selectors, so Objective-C API is defined by Apple. So if you had to write the same thing in Objective-C, it would be the same. More or less, syntax-wise, we're a little bit different. There would be a little bit more boilerplate code, but it would be the exact same thing. So RubyMotion doesn't really provide any magic here. So it's just, it provides a runtime that lets you call all the native APIs. And if you type rate, you get this on the simulator. For Android, it's a bit shorter, the hello world. But again, it is the same thing. We are using Android app activity, which is a Java class. We are creating a new Android widget text view, which is also a Java class defined by Android. So all this stuff is Java, but we call it from Ruby. And it just works because we have this unified runtime approach. If you had to write this in Java, it would be the same, again, same thing. If you type rake, you can get this on GameEngine if you install GameEngine, which is what I really recommend. If you don't, you can wait like 30 minutes, and then it appears on the Android emulator. So a little bit about static compilation as well. That's very important. RubyMotion is statically compiled, so it's not interpreted. So unlike the other Ruby implementations, we actually generate machine code once, then you actually run the binary. So it's very similar to C, C++, Objective-C, or even Swift programs. So we generate like a binary. So we convert Ruby into some intermediate languages, an abstract syntax tree, and we use the LLVM project to actually generate machine code. So you get a binary. So that's very important. RubyMotion apps are binaries. For iOS, it's actually an executable. For Android, it's actually a shared library that we load with Java. The original Ruby source code is never present in the application. That's very important. And RubyMotion apps usually weight a few megabytes. So there is no interpretation. A lot of people are confused about that. And the command line interface, very quickly, it's simple. You have the terminal and your favorite text editor. We can use any editor you want. Of course, you should be using Vim, but you have Sublime. No, I'm joking. Actually, you really want to use the editor you want. And so so Vim, Sublime Types, and TextMate and Emacs provide like the basic interface to RubyMotion. RubyMine offers a much better experience. Actually, there is a RubyMine presentation today, so we get to know more about RubyMine. But it provides smart auto-completion, point-and-click debugging, so which is more like an IDE environment. But basically, the idea is that you don't need to use Xcode or Android Studio. You can use what you like. A few things for those who don't know. Creating a project is from the command line. Motion create, you choose your template. Project configuration is a rake file. Everything is in the rake file. So you don't need to open Xcode or Xcode projects. There are tasks to run the simulator, the Android emulator, and to push on the device. Everything is using rake. You don't need to click on buttons, right? When you need to publish your app for iOS App Store, Android Play Store, there are rake tasks as well that give you a package that you can just send to Apple or Google. So that's very simple. These are all, everything is based on rake. So a quick part about RubyMotion as a business. We are 100% bootstrapped, so we never took funding so far. So we are basically profitable since day one, and we are mostly funded by our customers. So our customers are our investors. It's really by design, so we never raise money, and we want to stay independent, and we have like a long-term vision. And we have thousands of customers. I don't have time to talk about them now, but there are actually a lot of them here that will give presentations later for this conference. In 2012, we released the first version of RubyMotion with iOS support. In 2013, we released OS X support. In 2014, we shipped Android. This year, we ship a bunch of features. Some of them, I will show them to you today. There are two others that I cannot show you today, sadly, but they will appear later this year. They are very big, but you don't really master time, right? So is RubyMotion still hype? That's the main question, right? I don't know. So for that, we have a metric for if you want to know if a project is hype. You can check the number of articles on Hacker News front page. And actually, so I went back, and so to give you an idea, our revenue is relatively stable. I don't want you to think that we are crashing, but this is so this year we have 0 Hacker News front page article, as far as I know, and last year we had like 7 or 8. So yeah, so no more Hacker News front page. So I guess RubyMotion is not hype anymore. But if you look at this, hype means boring, which means stable, right? So yeah, someone say that Ruby is someone say Ruby is boring, and which is the reason why you actually pick Ruby to write. I think it was the Stack Overflow team. They decided to go with Ruby because they say, oh, Ruby is not boring, so it must be stable. So let's pick Ruby, right? Anyway, the future of RubyMotion. So the first thing that, for me, how I see RubyMotion in the future is obviously cross-platform gems. This is the #1 thing that we should really be doing, since we now offer iOS and Android. And if you look at the table here, as I say, you need to call the iOS SDK APIs on iOS and the Android SDK APIs on Android. So you need to replicate like code. And if you do networking, for instance, or user interface layout, you will have to like duplicate logic on each side, which is kind of boring. You can share, of course, pure Ruby code on both platforms, but you have to have specific platform code. So I think the future is that we add an additional layer here, cross-platform gems, which are RubyMotion gems that you can include in your project that provide a consistent API, but different implementations for each platform. And for that, of course, we basically need to build the rails of RubyMotion, right? But RubyMotion is like a compiler and a runtime, but we need to build the whole thing on top of it. So I'm not going to talk more about that, but basically, there are people working on that. It's called Red Potion and Blue Potion. So there are talks about it today and tomorrow. So I'm not going to cover that. Actually, I don't even know more about these projects. But they look nice, and this is probably what we should be doing, the future of the community. So this year we ship RubyMotion 4. We ship a new version every year, right? And so we're going to show you today a few things we've been working on. This is not everything we have been working on so far, but we prefer to show stuff that's really finished, to not give expectation. First, we really want to focus on Android because we shipped Android last year as a beta, then we ship it to everyone in December, and now people are starting to picking up for real development. And sadly, Android is not as stable as the iOS version. So we are working very hard. We are making builds pretty much every month with bug fixes, especially thanks to the Infinite Red people who filed a lot of bugs. So this is really our focus here. I would like to make sure everyone knows that. So we need to work on Ruby compatibility improvement. As far as we know, we are 60% compatible with Ruby instead of 100%. So there is a bunch of classes or methods that are not yet implemented. So we basically implement them every month. If you check the release note, you will see, oh, we added this method, we added this class. So we add them like when people actually request them, but we want to make sure that we are fully compatible. And there are performance improvements as well. Right now, RubyMotion for Android has probably not a lot of performance improvements, mostly because we wanted to ship something that's usable. But one thing we'll be doing is actually optimize the runtime. So we'll be introducing most of the optimizations that we do for iOS. For instance, we have been working on method inlining and method caching, things that we don't do for Android right now. So each time you call a method for Android from RubyMotion right now, we basically resolve the whole thing every time. And so we're going to introduce caching and a lot of optimizations, also for instance variables. So we want to make it as fast as the iOS version. And also in RubyMotion 4, there will be a new REPL. REPL is like the Ruby read-eval print loop. IRB, yeah. It's like IRB. And it's actually a whole new implementation. It's based on something that I originally wrote for Android. It's called the JetBridge architecture. And basically, the idea is that when you type expressions in the REPL, instead of compiling them and evaluating them in the application process, we do them on the REPL itself. So it's a bit complicated, but it's extremely important because this way we can make the REPL work on both the simulator and the device, which was really missing. So this is how it works. It's a bit technical, but basically, from the computer, we actually generate machine code on the computer itself, but for a remote architecture. So we are on our computer on Intel architecture, and we connect on an ARM device. So we basically need to. So we have like a communication protocol between the computer and the phone or the tablet, and we tell him, okay, allocate some memory, mark it as executable. And then the Mac will actually generate machine code for ARM remotely. And of course, it doesn't work like this. It's not. We have to do some work there. So we need to know the addresses on the device and back and forth. Then once we have the machine code, we can send it to the device, which will run it, and then it will free the memory. And this way it works on the device. The new REPL is also very configurable. So basically, it will allow the community to actually extend it. This is our goal. For instance, people have been asking for a debugging interface, and we want the REPL to be the debugger of RubyMotion. So right now, you have to use GDB or LLDB if you want to debug apps. and we want people to use like a Ruby syntax instead. So we want people to actually use the REPL as the debugger. So it's going to be there. And we'll show you a demo. Watson is going to do a demo for you.
Hi guys. Hi Watson. I'm Shizuo. Okay. Now RubyMotion REPL works with iOS simulator only. In the future, new REPL works on iOS device too. This window is QuickTime Player. This window shows my iPhone screen. Okay. Okay, terminal. Thank you. Okay. New REPL has two features. One of the feature, of course, like device. You can evaluate the expression on the device. Now loading.
Yeah, it's loading.
Okay. Oh, it is new rep. Okay, works.
So there is no magic here. The application is here. So there are no cable.
Yeah. This is one of the features. You can evaluate the expression on the device. Next feature, code reloading. When you change the application code with editor, the changing will be applied immediately. Hello world. RubyMotion inspect. Save. Yeah.
Again, no tricks.
No compile. Okay. This is new REPL. Thank you.
Okay. And the next one, sorry, so thanks, Watson. Watson is working on that, and it's almost ready to ship. So, I forgot to mention, so we decided to use RedPotion for this sample, and it's using the same code reloading code that German has been working. Where is German? Right there. So it's the same, more or less the same thing that you wrote. Awesome. No, it works on the device. That's great. The next thing we would like to talk is the Apple Watch, right? And I have to give the micro to Mark.
Hi. Yeah. So how many of you have one of those things? I think quite a few of you. Okay. So last year, Apple introduced the Apple Watch. And then they gave us the first version of the SDK, which was WatchKit. This is the first version, and it was a bit limited in capabilities. So it consists in two parts: an extension that runs on the iPhone device, and then some interface resources that are installed on the watch. So this was introduced in November of last year by Apple. And we had support for it, initial support in RubyMotion in December, right? So some of you already started creating applications. And now Apple has introduced WatchOS 2.0, which is like the second version of the operating system in the phone, in the watch. It is an evolution of WatchKit, but now apps run natively in the watch. So the whole thing runs in the watch. And you can get access to capabilities in the watch, like the digital crown, the force touch, or the heart rate sensor, right? So this was introduced in June at WWDC, just barely a month ago. And I want to show you something. So this is the new. Yeah, okay. So this is the new watch simulator, now Xcode 7, which is in beta right now. Ships with two simulators. One is the normal iPhone simulator, and one is the watch simulator, which runs a full version of the watchOS 2 system. So since I bought the Apple Watch, so you know the dollar has been going down and has been going up in price since with the euro, and I'm from Madrid, so I've decided to invest all my money in Bitcoin because the euro is going down right now. So I wanted a quick way to be able to check the current rate of Bitcoin, the Bitcoin value. So I decided to make an Apple Watch app, right? And since I don't always have my phone with me because iOS 9 gets a lot of battery, sometimes it goes out, I needed to build a native watch application to be able to do it without the phone, right? So I took my previous WatchKit application that I already made back in December, and I literally just added one file to the project and changed one string, and yeah, there. It's updated. And you have a full LLDB. So you can refresh here. You can refresh the price. Of course, this hasn't changed. So Bitcoin it's stable, like RubyMotion now. It's fully stable.
Sell.
And you have a full. Oh, I exited by. Okay, so there's a full LLDB prompt there, so you can debug the application. You can log, do print development, print debugging. So yeah, so this is it.
Okay. So the watch stuff that Mark has been working on is kind of tough because it's actually a new platform as Apple is showing it. So it's also there is also a new architecture on the watch. So we're working on that, but we want to support, of course, native apps on the watch. So this is going to be in RubyMotion 4. And the last thing I would like to show you today is a game API. And this is something I've been working on personally because it really makes me happy to work on games, right? Who wants to work on compilers? So, well, basically, the idea is that we would like to write mobile games in Ruby, but real games, real native games. So the stuff is 100% cross-platform. This is actually really cross-platform. So you run one code base, it runs on iOS and Android. No, you don't have to write platform-specific code. So this is just one project. In the same project, you have like a one directory for source files. You put them there, and it's going to compile them for both platforms. And the game API is fully featured. It has a bunch of stuff that I've mostly have no idea what they are. Like the scene graph, I can accept events from the sensors. You have a sprite, a concept of sprite, which is basically a graphic image. Then you can apply animations to. You have a bunch of UI user interface widgets, so you can create buttons, lists, windows, bunch of stuff. You have a networking API there. You have stuff to do parallax effects for 2D games. You have a particle system. I use it a little bit. It's nice. You have physics, of course, so you can apply physics to your objects, and you have animations, of course. And obviously, since I know nothing about video game, I actually use something that's very stable, Cocos2D-X. So we basically wrote a Ruby API on top of it. So Cocos2D-X is the most popular game engine for mobile by far. Most of the game, that's what they say. So maybe they lie, but I think it is. And a lot of games are using it on the App Store, and it's basically written in C++, and it has a JavaScript interface, but JavaScript is not native, so it's basically interpreted. So when people write games in JavaScript using Cocos2D-X, they start to hit limitations, runtime performance, and they cannot use threads because, of course, JavaScript doesn't support threads. So here with RubyMotion, we wrap this in Ruby instead. But it's the same thing as RubyMotion, so statically compile it to machine code. And you can also call the iOS APIs and the Android APIs if you want. Normally, you shouldn't have to, but if you have to, for instance, interface with GameKit on iOS or the stuff on the Play Store for Android, you can do that. So you get like a modern language, but native performance. And we also do that because we believe that games are very popular and are definitely the biggest market right now on the App Store. I think that half of the revenue of the iOS App Store comes from games, and games are like 25 or 30%. Maybe Amir knows more about that, but games are big, yeah. And yeah, I want to write games, so that's the reason. I'm trying to give you a reason so that I did that, but so I'm going to show you a demo of the game engine, right? Where is my system preferences? Where are we? Close this. Yeah. So yeah, I really like David Hasselhoff. I mean, no, actually, I will show you. This is actually a gem that Boris wrote. Boris is right there. So if you type Hasselhoff, it changes the background. The new one here. Okay. So you can try it again. And oh, this one is nice. I'm gonna keep this one. Okay, that's okay for you, or maybe. Oh. Oh yeah. Okay. Okay, I'm gonna keep this one.
That's got to be a code of conduct violation.
Sorry. So did you know that David Hasselhoff is super popular in Europe? Like very, very popular, more than America, I heard. Yeah. I think in Germany it's like very, very big. Yeah.
Well, because he's a singer.
Yeah. So here. So here I'm gonna show you a hello world in the game engine. So this is, sorry. So let me show you. So this is like a hello world project in the game engine. So can you see that, right? So as you can see, there is an app folder with a bunch of Ruby files, and these are cross-platform. So the stuff you write there will be compiled for iOS and Android. Build is the build directory, so you have a build for iOS and a build for Android, of course. Config there are actually reg files there for both iOS and Android. Config is there. So basically, you have a common reg file for both projects. And then if you want to change iOS settings or Android settings, you have 2 files here. These are actually extending. So if, for instance, you want to change the icon on iOS, you can tweak it there. everything that's common. If you're a little bit familiar with the RubyMotion build system, you know that there is a config class, then there is an iOS class that inherits from it, and an Android class that inherits from it, and there is a bunch of stuff that's common. So the common stuff is in the main reg file, and the other stuff is in the iOS and Android stuff. And then you have resources, which are stuff that you can put there for your game. And then you have tests. We don't have tests yet. It will happen eventually. So this is hello world. So if I type reg iOS simulator here, it's going to build my app, and I have hello world here. I forgot to show you the code, of course, but this is hello world, and I have my REPL here, of course, as usual. So the main object here is always the main scene. Oops. This is hello world in a RubyMotion game right now. So the API might change a little bit, but it's mostly what it is. So you can create a label here. Anchor point is basically where you want the label to be present on the screen. So we say 0, 0, which is the middle. So we want to be there. And then we add the label on our scene. Anyway, I can type reg Android emulator here. And I have GameEngine here. So you need to wait that it installs. Okay, it starts, and what's happening here? Oh, hello world. Right, this is the same code base, but it runs on both platforms. And again, it's the REPL here, same as you know, right? No, of course, this is boring, so I'm going to show you a Flappy Bird. Yeah. So here I have a version of Flappy Bird. No, ça marche. It's working. Yeah. I have a version of Flappy Bird here in 100 lines of Ruby. I actually commented some of the code so that I will uncomment it as far as I do the demos that you can see. But basically, so this is Flappy Bird. So it has a concept of a skyline, a ground. Everyone knows Flappy Bird, right? You play Flappy Bird, you've seen it. So it has a concept of a skyline that's actually moving. A skyline, like the sky, cities, grounds, and there is a bird in the middle. You need to basically avoid pipes to win, right? So you can read that, right? So our initialize method, this actually has to create all the objects on our scenes. For instance, for the skyline method, we create 2 sprites, and then we add them on the scene. Why do we create 2 sprites? It's because we want to create an illusion of movement. So we're going to move the 2 sprites like this, and when the first one is actually hidden by the screen, we're going to put behind the first one, behind the last one, and this over again. So it creates the illusion that there are many images where there are only 2. And I have no idea if it's the best way to do that. I figured it out by myself, but the ground is the same here. So I have a method here that does the same thing, 2 ground objects. These are PNG files that are actually in the project. So I actually stole them from someone on GitHub. My bird is the same. My bird is different. I have this animate method there. I can provide as many PNG files as I want, and they will be animated. The HipByte method, I'm not going to talk about it yet, but in my update method, update is like the main entry point of the scene, is that this method will be called for each frame. So more or less 60 times per second. So you should keep the update method as small as possible. You should avoid to do logic there. But here, I actually moving my background pieces. So for each background piece, I actually move them for 1 pixel, right? Then when it reaches when it's no longer visible, I put it back in the first place. This is how I actually simulate movement. So there are other ways to do that, but I don't know what I'm doing. So I did that. And this is all. Everything else is commented. So I'm going to type reg here. And this is my Flappy Bird, right? So right now I have my bird that's actually animating, as you can see, and the skyline and the ground are moving, and I have my REPL here. But I can actually access my bird instance variable here. So you can see it's a sprite, and I can ask for its position. It's 100 and 564. I can actually tell the bird to move somewhere because a bird responds to action. So I can say move by, and one pixel on the X and 0 pixel on the Y. And I can say do it in 2 seconds. So it's going to take 2 seconds to move 100%, right? So I can say move faster now, 0.5, faster. I can say go back to where you were. So oops. So it's minus 200 and do it right. Oh. Yeah. Okay, right? You can actually move there. So like move there. No, not move to. Right? So you have a bunch of actions there that you can animate with your bird. And there is also one that's blink. That's actually very cool. You can make it blink like 5 times in 1 second. So it's blinking, right? I like it because it's like, you know, in these old school games, when you reach an obstacle, things blink. So I like old school games. So, so that's basically our Flappy Bird here. Now I'm going to actually add physics there. So there is a physics engine in the API. So I can actually set up gravity. So which means that here there is a gravity of 0 and then minus 900 something. I don't know the unit, but since it must be important, right? So minus something. So it's like the hertz. And I'm going to uncomment this. So every time we receive a touch event, we are going to apply a velocity on our bird, which a velocity of 0 and 200 y. So which means that every time we touch, we'll actually make the bird jumps for 200 pixels. So right by default, the bird will actually fall, and every time we click, it will actually jump. Then here, when we add our ground, I'm going to attach a physics box to my ground images. So the ground is actually the very bottom of the game. So I'm going to say you need a physics box. And so I have 2-bit max here. I forgot to show you. I have a bird and world, which are actually 2 numbers. So I decided to create 2 categories, one for the bird and one for everything else, which is an enemy, right, an obstacle. So I call it world. I could call it like evil or something, but so my ground object has the category world, as you can see here, but the contact is bird. So it basically means the ground is actually known as the world, but it can only contact the bird. And I'm going to do the same thing for my bird. I'm going to attach a physics box. Then I'm going to say the category of the bird is bird, of course, and it can contact with the world. And finally here, I'm going to, in the update method, so the method that's actually updated one for every frame, I'm going to actually rotate the bird based off its y velocity. So the bird is actually like this, and if the bird is actually going up, we want the bird to rotate like this, right? If it's falling, we want to do that. So, and don't ask me how I came up with this Ruby expression. I have no idea. I tried it and it worked, and I said, okay, that's
Basically how I program.
yeah. You try and fail. So I'm going to compile the project again.
I'm still using a room full of monkeys.
Oh, here we go. As you can see, oh, there is a sound I forgot to mention, but every time you tap, there is a sound that's being played. And so if I leave, the bird is falling, right? It falls on the ground. So the bird is actually, the gravity is affecting the bird. I can actually change the gravity here. I have my, so self is my game scene, so I can do self.gravity, which is 0 minus just 19, right? And I can change it to 0, 300. I know the bird is going to fly because the gravity is reversed, right? So the bird now is this. It's going high. It's reaching the sky, right? So I will change gravity back to something negative, like 0 minus 500, and technically the bird should fall. Yeah. Oh no, it's going up. No, it's not affected anymore. It's like no, it's falling. Yeah, it's falling very slowly. I can actually say position equal 100, 400. Where is my bird? Oh no, it's minus something. Oh, my bird is lost. I'm afraid. Sorry. Anyway, as you can see, I know nothing about video game programming, but it works. Believe me, I didn't write the physics engine, so it should be good. So now I'm going to finally here in my update method, I'm going to uncomment this code. Basically, we will call the @pipe method each 2 seconds. So how do I know each 2 seconds? I can actually, the argument of the update method is the number of seconds since the last update. So I can actually keep an instance variable and increment it here, right? And if it's over to the 0, I know that it has been 2 seconds since the last time. So I can actually call a method and then go back. And @pipe here is very simple. This is the method. I actually create 2 sprites, up and down, because the pipe has 2 pictures. And I attach a physics box. I say it's the world, and it contacts the bird. And finally here, I actually call the move by method. I say, as soon as I put the pipe, I actually move it back to the negative x. So I want the pipe to actually move to the left. So if I do that, my pipe will appear. And finally here, I can actually create a handler for collisions. I can say that if the physics engine detects a collision, if the bird reaches the world, I want to play a sound, and I'm going to put something on the terminal, right? Normally, you want to present a game over screen here, but I don't have time, so put game over, it's fine. So I can just type break simulator again. And now I have to be quick. Oh. Okay, so my pipe are appearing. Too late. Game over, right? So, yeah. So let me try again. I will be better now. Okay. Okay. Okay, so you can. This is working, right? Ooh. Then you can actually use the pipe to go faster like this. Oh, oh. Ooh. Ah, yes. Ooh, no, too late. Anyway, you see the. Okay, it's there, right? And I would like to show you that it runs on Android as well. So if I type Android emulator, it should work. The problem is that JetBridge is a little bit weird sometimes. So so you will see that it's actually going very fast, like super fast, but yeah, but believe me, it works on the device. No. So here I have my game. It's the same code base, right? Yeah, it's faster. Yeah, it has more frames. It's 60 frames per second on the Android stuff. The simulator has the simulator is 30 frames per second. On the device, it's 60. The simulator is twice, but it's the same. Yeah, same game, right? So this is it like. Sim preferences, displays, regimen. Oops. Where is Keynote? Where is Keynote? Oh. Oh, we lost Keynote. No. Oops.
Just type asset off.
Oh, Keynote was.
We'll fix it.
Keynote was dead actually. Yeah. So this is motion game, right? So yeah, so motion game API, 100% cross-platform. I didn't write the game engine, so it should be good. I wrote the API. So RubyMotion 4. So this is going to be RubyMotion 4. And so we do a pre-release with all of the stuff that we show you. You need to give us like a few vacation days after the conference, but then we do a pre-release. The pre-release is like available for everyone, so you can download it. It will really ship to everyone later this year, the same as we did for Android. So first we ship pre-release and we ship the real stuff. There are 2 more secret features in RubyMotion 4 that we don't talk about it today for many reasons, but they are actually very, very interesting, but they are going to be announced later this year. I can't tease. I can't. These 2 features are actually written in partnership with a bigger company, so I have to. That's the only thing I can say. So we also want to refine our pricing strategy this year. We are actually starting today by. So we are going to do monthly subscriptions now. You can choose monthly or yearly. We believe that it's going to reduce the friction if people want to try RubyMotion. The cheapest is $20 per month. So you can. We believe that it's going to. We actually tried. So I actually ran this. I did A/B testing. I know nothing about marketing, but A/B testing is interesting because you have data, right? Data doesn't lie, so I like it. I mean, as a programmer, I like data, so I did A/B testing, and so we actually run monthly pricing since at least 2 months for 30% of the traffic, and we actually track if it was working, and it's actually working. So now we are shipping it to everyone. And we'll do other pricing changes later this year, drastic changes probably, but it's going to take time for us to think about that. But basically, yeah, the idea is that we would like to change it a bit the way we charge for RubyMotion. And that's all. So that's all for this presentation. So thank you. I think we ran out of time, so we can probably do like a few questions and then we can go back to the other room. Is it hot here? I guess. Are you fine? Okay. We can go back to air conditioning ward. So if you have questions, you guys have any questions, or we can go straight to the other room. Oh.
Does the game layer supplant? I'm asking if the game layer supplants the entire sort of SDK layer, or is it something you can use sort of in a box inside of a more traditional UI?
Yeah. So absolutely. So the default template is actually over the SDK thing, but you can actually use it inside an existing app. So I will show you that later. But basically, for Android, it's a different application delegate. Activity class. So you can actually if you already have an activity class in your Android project, you can just integrate the GameEngine there. And for iOS, it's a UI view controller. So yes, you can definitely have like a pure RubyMotion project and just use the GameEngine there.
Because it seems like it would be useful for, I mean, one of the sort of pain points is drawing, just almost anything. So it seems like it could be useful for that.
Drawing, yeah. Yeah, drawing. And so there is a user interface, also a UI library, like buttons and library endtypes. But I wouldn't want people to use it to make relapse because it's going to look like So which is why we're going to be a bit careful about that. Just said it's free for games, right? Not relapse. Relapse should be used in native controls. But yeah, so you can embed it. It's and it's Ruby code, the GameEngine, so you can hack it any way you want. Questions? Yeah.
So the REPL is really great for doing code evaluation and things like that, and accessing like global variables and things like that. And as Rails developers, we're used to having like a stateful REPL, like using a gem like pry.
Yeah.
Are there any plans to add that sort of thing into RubyMotion so I can actually put a line of code in and then when I'm debugging it, I actually get that state and I can access local variables and things like that?
Yeah, so this is exactly what we plan to do. We would like to actually implement something like pry, the exact same interface. Yeah, yeah. And ideally, we would like the community to do that. So we actually provide the API, But yeah, we pre-write like a proof of concept or something. I think it requires more work, and I don't think anyone on the team has experience with Spry. Do you? Do you have experience with Spry? No. So if you have experience with Spry, and we show you like how it works, and you can pre-write it if you want. Shouldn't be very hard, I think. Oh yeah, this is the goal. So we want the REPL to be the official debugger. So no more GDB or LDB. So we do everything we can to support what the Ruby people like. So I never use Spry, so I have no idea what it is. To give you an idea, right? So, but we will do it.
Thank you.
Yeah.
So the live reload, does that work in Android? It does work in Android. That's good. Yeah, that's pretty awesome.
Hello. Yeah. So yeah, so it's working on Android.
Awesome. And then one of the big things that I ran into when I was trying to implement it with Todd earlier this year was if you had a typo in your code, then the whole app would crash. And we were trying to rescue that. Have you gotten past that to where it'll just show the exception?
Yeah. So for that so I didn't mention it in this presentation, but we're working with 2 companies to provide static analysis to RubyMotion. And the idea is to integrate this in the build system, so that as soon as you type at build time, you will know that, oh, this selector probably doesn't exist, or this content doesn't exist for sure, and then we do like fuzzing, like to say, oh, did you mean this instead? You see what I mean? So we do that. So we work with 2 companies, Code Climate and Pull Review. They are competitors actually, so we let them compete, right? We pick the best one.
And that
Yeah.
will happen just in time as well as you're doing live reload?
That's a very good question. Huh. So right now the focus is on the base system.
No more questions.
No, but you actually you make a very good point actually. Yeah, I guess we could, like, if we can feed with just a string of Ruby code, that would be great, and say, oh, is there any problem there? And then you can just, yeah. We could try. I mean, so these companies are building something extremely different. Like Code Climate they're actually, so as far as I know, they have like their whole platform is actually a virtual image that you use on your machine. So it's kind of big, right? And it talks with a web service. And the pull review system is different. It's like very small. It's written in C++ code base, and it's really it's not part of anything like web stuff. So, and I have no idea how they work both, but they want to do that. So, questions? Yeah.
The REPL changes, is that also for Android?
Yeah, of course, yeah.
Okay.
Yeah, actually, the stuff I show is already in Android.
Great.
So we already do the JetBridge architecture, because for Android we couldn't actually we cannot use LLVM inside. So for Android, people use the device for development. They don't use the emulator. So which is like we have to run the REPL on the device, and we can load the LLVM compiler on the device. It doesn't work. It's not. It's designed to be hosted for on Intel machines. So this is how I came up with this JetBridge ID.
Got it. Cool.
Yeah, but the whole it would be, so right now there are 2 code bases: the REPL, the Android REPL, and the iOS REPL. And with this, there will be only 1 code base, and we will put all the features of the iOS REPL in there, and it will be like the same thing. And so that's going to be the new REPL. Okay. I think we can call it a day, right? So let's get some drinks. It's a bit hot here. Thanks.